Okay, let's take a look at this is a 13.2 through 3 mixed review from Algebra 2, so some problems that'll help us get ready for the test. Let's take a look and run through each of these real quick. Um, so the first few were just kind of drawing an angle in standard position. So, there's no trig value, there's no reference angle, nothing, just draw an angle. So we're thinking negative 95 degrees. So if you usually kind of get started on the positive x-axis, normally a positive angle would go upwards through quadrant 1, but this time we are negative. So we're just going to go a little bit past negative 90, so somewhere down there. That might have even been a touch too far, but good enough. There's our theta, 95 degrees. Okay, I know some people had done the add 360 thing to it, and that's fine. You can go ahead and do that, and you should end up getting 270, or yeah, 265, right? 265. And notice if you do that, if you think of it as a positive 265, that would just be kind of coming around this way and leaving you just short of the 270. You'd end up in the same spot. So technically for this one, if you're showing the angle, you do it the way I did in red because it was negative 95, but it would end up in the same spot as a positive 265. Okay, number 2. Let's see. Okay, number 2, same deal. They give it to you in radians. So you might want to convert. I know we've been a little more comfortable with degrees. So if you go ahead and do the conversion factor, the 180 over pi, and end up doing the multiplication, the pi's will cancel out. You get 5 times 180 and divide by 3. Ends up being 300 degrees. So that one we should recognize again. It's going to end up in quadrant 3. And um, let's see, 300. Oh, I'm sorry, I misspoke. Quadrant 4 actually, because we are a little bit past the 270. So if we start in the positive x-axis, we work our way around a little past 270, end up something like that. That would be your 300 degree angle. Okay, and again, if you're thinking radians, that's fine. If you just remember this is of 1 pi, so 90 degrees is half of pi. Down here we're at 3 pi over 2, which is like 1.5 pi. If you want to think fractions and stuff after we do a little bit more unit circle stuff, the radian version won't be too bad, but no problem converting to degrees. Okay, number 3, now we're talking about reference angles. They actually gave you the angle of 250. So the reference angle, again, you always think about where does your angle terminate and get you back to the x-axis as quickly as possible. So this angle measure here is going to be our reference theta prime. So you can think of it as they went past 180 to get up to 250. So our reference angle is how much past did they go, or basically just take the 250 minus 180, and you should get an answer of 70 degrees for the reference angle. Okay, and it might seem a little weird. I know the reference angles are usually 60 or 30 or 45, but it can technically be anything. We just couldn't ask or find the sine of that or the cosine. We couldn't find a trig value of it, but we can still find how big the angle itself is. Okay, so that one was 70 degrees. Number 4, same type of problem, except that they gave you in radians. So let's get that mark off there. Problem 4, clear the ink. So they give you 8 pi over 3. So again, if you want to change to degrees, that's fine. So if we convert to degrees, times the 180 over pi, you end up getting 480 degrees. Okay, so that's the degree equivalent of that. So as we can see here, we're doing the full circle. There's 360. So to figure out how much more we did, if I subtract off 360, I can get 120. 120 is a coterminal angle. The 120, let's use red here, that's going to be from there to there. Okay, that's 120 degrees. So in this problem, our reference angle, just like always, asks you from the origin, so our terminating side, back to the x-axis, there's some reference angle, theta prime, in there. And we just figured out that this opening was 120. Okay, so we can do 180 minus the 120, and we can get our reference angle in quadrant 2, and in this case it should end up being 60 degrees. Okay, now to get full credit and to be, totally, exactly what they want here, they started us in radians. So we did a little conversion, but technically, if they're giving you something in radians, they're going to want their answer in radians. So I would take that 60 degrees and just convert it back real quick. So back into radians, we would multiply by pi over 180. Right, and then you should see when you reduce the 60 over 180, you're going to get 1 over 3. So it's going to end up being pi over 3, and that's the way we're going to want the answer. I'd probably take off half a point or something if you left it at 60 degrees. You showed me you knew the process, but technically they want it in radians. So if you're going to convert to degrees, you better be able to convert back. Okay, number 5 then, we want to find the secant of some angle. They give us a point on the terminal side, so they give us an x and a y. Okay, so this is one of those problems where a picture might be helpful. Okay, I know that the x value is positive 7, so out here somewhere. The y value is positive 15, so that's just a little bit less than 4, so I don't know, maybe up there somewhere. And our angle goes through, or that point I should say, is on the terminal side. We have some angle here. The coordinates of that point are 7 root 15. Okay, so a couple ways to think about it. You could go right to the x, y, and r definition if you want, but just to kind of visualize what's going on, if we were to drop straight down and make a right angle here, we can see the adjacent side, that's just the x value, that's the 7, that's how far I went out. Okay, and then your hypotenuse, or I'm sorry, your y value is the opposite side. That's the root 15, and we don't know that r value, the hypotenuse. Okay, and for this problem, I think we need it. Okay, secant again is reciprocal of cosine, right? And cosine we should know is adjacent over hypotenuse, x over r. So secant is going to be the reciprocal of that. It's going to be r over x. So we do need r in this case. We do need the hypotenuse. So that's just a little Pythagorean theorem. Remember the formula that always holds, r squared always equals x squared plus y squared. Okay, r squared, we know x is 7. The y was the square root of 15, but that needs to get squared, so 7 squared is going to be 49. Root 15, when you square it, isn't it just 15? Yep, just 15. All right, so this will be r squared equals 64. So the radius r, the hypotenuse ends up equaling 8. And then we can go ahead and write our ratio. Now the secant is going to be, for a final answer of r over x, so 8 over 7 should be your final answer there. Okay, number 6, another similar problem. They gave us coordinates again of a point on the terminal side. So this one, again, they give us an x and a y, and I'm looking here, I need tangent. Okay, and if you think again, tangent is always opposite over adjacent, and the way we draw these, with the reference angle, reference triangle, the opposite is just the y value, and the adjacent is the x value. So tangent of theta is just y over x. So you don't even need to find r. Okay, you don't need the hypotenuse for a tangent problem, do you? Okay, so let's just not do any more work than we need to. It's just negative 9 over negative 3. We reduce that down, positive 3. That one's done. Okay, let's see, finding exact trig values. So they gave us the tangent of 315 is what we need. Okay, so let's set this up with a little picture and see what we got going here. So 315 is going to be down in quadrant 4. Okay, it's actually right in between 270 and 360. It's right in the center there. So I know my angle will start standard position, work its way around. Okay, there's theta. That's the 315. Okay, and it actually gives us a good little setup for a reference angle here. Because again, if we go straight back to the x-axis, make a triangle out of this, there's theta prime. Okay, there's our reference triangle. So if we went 315, the green, the reference angle there, to get us back to 360, minus 315, we should be able to recognize there's still 45 more degrees to go. So that's our reference angle. Okay, so this guy right here is 45 degrees, and we're going to use that. Okay, the tangent of the reference angle, okay, if we look back on our sheet, or again, if you forget this, you're going to have to set it up. If you don't have it memorized, go ahead and draw the 45, 45, 90, right? At any time, if you get stuck with those, memorizing those values, remember the side lengths, and go ahead and figure out what the tangent is. Tangent's opposite over adjacent, so x over x. So tangent of 45 is just 1. Okay, so for our problem, we don't want the tangent of 45, we want the tangent of 315. Okay, so we just got to determine is it negative or not. Now don't rely on the options here. I know this is multiple choice, so it's negative 1's probably going to be the way to go, but if it's not multiple choice, we need to be able to set this up. So here's how I figure it out. Okay, um, in the reference triangle we drew, technically the opposite side is a negative value. Okay, because we're in the fourth quadrant here. So the y values are negative, the adjacent side is positive. Okay, because the x value there is going to the right. So tangent is an opposite over an adjacent. It's a negative divided by a positive. That's why the actual answer is negative 1. Okay, because for our angle, it's actually a negative y value over a positive x value. Okay, so A for that one. Okay, and the last three problems were all a little bit similar. They all ended up being borderline. They're like quadrantal angles. They're right on the borderline. Let's see what I'm talking about. So if we take this angle, again, let's probably work in degrees. If we take the 11 pi over 2 and we times it by 180 over pi, okay, let's see what that ends up equaling. So we can draw and see what the reference angle gets us and everything. So again, the pi's will cancel out, and when you do the multiplication, you should end up with a 990 degree angle. Okay, so that's kind of big, definitely a few rotations. If we subtract 360 a couple times, okay, I gotta do it one more time, we get down to a more manageable 270 degrees. Okay, so 270 is an angle that looks just like 11 pi over 2, or at least it ends up in the same spot. It's coterminal, right? So 270 is going to be here, straight down. Okay, so in this case, it's kind of hard to figure out what the reference angle, I guess technically it would be 90 degrees to get back to the x-axis, either if you're over here or over here. Either way, it's 90 degrees, but we kind of handle these a little bit different. And what we do is we're going to go back to the definitions of using x, y, and r. So if you think about it, let's fill that in there. If there's some point down here on the terminal side of our angle, okay, the coordinates of that point, the x and the y value, I always start off with one of them is going to be 0 for these special angles, and in this case it's the x. The x is 0, okay, because we're not to the left or right any, we're directly on the y-axis. Now the y value is basically, it's a negative value, okay, because it's down below here. Now we just don't know how far it goes. Okay, now once we've done the unit circle, we know we can use 1, but for now, we don't know that this is a unit circle, so I just know whatever the radius of the circle is, that's going to be the y value, and it's negative. Okay, so that's x, that's y, um, r is just r, okay, we're not messing with the r. So now we can set up, what is secant? Which ones does that use? So I think of secant as being the reciprocal of cosine, and I know that cosine uses the adjacent x over the hypotenuse, right? So secant must be the reciprocal here, r over x. Okay, so for our problem, again, r is just r, x in this case is actually 0, so when you have r over 0, you end up with an undefined expression there. The secant down there is going to be undefined. Okay, number 9 ends up being similar here. The cosecant of 90 degrees. Okay, let's get this ink off here. So 90 degrees, again, it's right on the borderline. Okay, the angle is standard position, goes straight up here. Okay, there's a point here, and it's similar to the last one where the x coordinate again is 0, Now the y-coordinate up there in this case, it's positive because it's up, and its distance is r away. Okay, again, if you're using the unit circle, we could use 0, comma 1 up there. Okay, and it would still work out. You get the same answer because r would be 1 if the circle is known to be a unit circle. Okay, but at this point we're talking about any old circle with any radius r. Okay, so now we can just do the definitions. Cosecant, again, I know is the reciprocal of sine. If sine's y over r, cosecant's going to be r over y. Okay, so for this problem, r is just r. In this problem, y is also r. Okay, so r divided by r is just going to give us 1. Okay, so the cosecant of 90 degrees should get you 1. And finally, and one more similar problem, negative pi. So again, pi is 180, so if you want to go um, degree mode, the secant of negative 180. So when you draw negative 180, okay, if we start here, and negative 180 is going to go down this way, we're going to end up over there. Okay, so note that's actually the same as positive 180. They're equivalent here. So the point is, though, our point is here. It's one of our borderline. It's on the quadrant borderline, so it's quadrantal is the term. Um, this one, the y value is 0. Okay, this point is not up or down anything. The y value is 0, the x value is r, but it happens to be negative because it's over to the left there. Okay, and again, r is just always r. So if we want the secant, again, secant goes with cosine like the previous example. Secant is always r over x. Okay, so for our specific example, it's r over, the x value is negative r, and r over negative r should simplify to negative 1. And that's those. So just remember, you can always use the xy definition if you know the coordinates of a point on the terminal side, which we kind of used these borderline ones. That's kind of the way we went there. All right.